Hey guys, this is Kerry, and this is the answer key to the down payments extra credit. So these are some problems that tend to look scary, but actually turn out to be a little simpler algebraically than you might expect. So I anticipate we may need a calculator for these. So I've got a calculator in front of me, and hopefully you do as well. Feel free to use Desmos online. All right, so before we get to the Regent-style problems, we're going to learn about some new vocabulary in the context of down payments and loans. So Xavier is buying a car for $16,500. He puts down a down payment of $3,000. So what a down payment is you might not be able to afford the whole $16,500 when you first buy the car. So what you can do is you can pay a part of it. This is the part that you pay when you buy the car. If Xavier takes out a loan from a bank which does not charge interest to pay for the rest, then how much will he have to pay back to the bank? So since the car cost $16,500, he has a down payment of $3,000, which means he pays the $3,000 when he buys the car. That means that he'll have to take out a loan for the remaining $13,500. So this is the amount he'll have to pay back to the bank. Okay, so that's actually the whole idea. Down payment is what you pay when you first buy the car, and then the rest of it is something you'll have to take out a loan to pay. So Stacy is buying a house for $535,000. So this is the price of the house. Most people can't afford to just buy that in cash. So she's going to put down a down payment on the rest of the house. So what that means is, or on the house, what that means is she's going to pay $120,000 immediately when she buys the house. So what she'll have to do is, since she pays this immediately, she'll have to pay $415,000 she still owes. And to pay that, it looks like she's going to take out a loan from the bank to pay the rest. So she'll take out a loan for this amount. In order to completely pay back her loan, Stacy will have to pay back the whole $415,000 that she took out. All right. The total cost of Amber's first year at school is $28,000. If she pays $4,000 up front, this sounds like a down payment. Then how much money will Amber have to pay back in total to completely reimburse the loan if the loan does not accumulate interest? So because the total cost of her first year was $28,000, she pays $4,000 up front. She still owes $24,000. If Amber takes 48 months, 4 years to pay back this amount, and she pays the same amount to the bank each month, then how much will she pay back each month? This is called Amber's monthly payment. So to compute Amber's monthly payment, we know that she'll have to pay back a total of $24,000, and she'll be able to divide that into 48 months, 48 pieces, and pay back a piece of it every month. So let's see how much she owes each month. 24,000 divided by 48. That is $500 per month. And this is frequently the way that people have to pay back things. Oftentimes we're not able to afford $28,000 right up front. So what we have to do is we have to take out a loan and then pay it back gradually over a long span of time, say 4 years or 20 years even, or 30 in the case of houses. Okay, so on the back of this page, we'll look at loans that charge interest. So oftentimes when you take out a loan, rather than just having to pay back the remaining cost that you owed, to make it profitable for the person who's giving you the loan, what they'll do is they'll say, okay, the longer you take to pay this back, we're going to add an extra small percentage onto it that you'll have to pay back as well. So when you take out a loan, you oftentimes end up not just paying back the amount that you borrowed, you'll have to pay back something called interest, which is extra money on top of the money that you borrowed. When the loans you take out charge interest, it says it right here. So when the loans you take out charge interest, you have to pay back more than what you originally borrowed. This is how loans usually work in the real world. The formulas to compute the amount owed or the monthly payments can be complicated, but if you're given the formulas with some care, these problems are not too difficult to solve. Let's see how complicated these formulas look. Oh my god, that's crazy. All right, so let's see. I think we can handle it there. So the below list includes a formula for relating the amount of a loan and the monthly payment required to pay back the loan in a set number of months. So P sub n is the present amount borrowed. N is the number of monthly pay periods. PMT is the monthly payment. So this is actually one variable, not three different variables. That makes it a little easier to look at. And I is the interest rate per month. Using the formula below, I guess it's actually above, determine the monthly payment of a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 payment to the nearest cent. All right, so for part A, we're going to be using the formula that we were given. P sub n is equal to PMT times 1 minus 1 plus I to the negative n power, all divided by I. And we're really lucky in this problem. We didn't have to derive this formula. It's just given to us. So even though it looks crazy, I bet we can figure out pieces of it. So the present amount borrowed is the first variable that we encounter. If the car cost $21,000 originally, and we did a $1,000 down payment, then our loan is $21,000 minus the amount that we did for the down payment, $20,000. So that will be the present amount that we borrow when we first start off. The monthly payments, this piece right here, which I'll put in a pink box. It says to determine the monthly payment, so that's actually our unknown. We'll call that X. Here we've got 1 minus, 1 plus, what is I? I is the interest rate per month. They gave us that. The monthly percentage rate was 0.625%. But just like normal, when you're given a percent, you have to convert it to a decimal before you plug it in. So that will be 0.00625 to the negative number of monthly pay periods. So since it's 5 years, the number of monthly pay periods will be 5 years times 12 months per year. That'll be negative 60 in the exponent here. And it's all divided by I again. That's not the imaginary number I. That's the interest rate, which as a decimal is 0.00625. So this problem looks terrible to solve, but from here it's actually just a lot of calculator math. We get 20,000 is equal to X. And what you'll notice about this red group here is there's no variables. This is just numbers. So you can put this in on your calculator. Now you do want to be careful about how you plug it in. It's going to be this whole top divided by the bottom. So use parentheses wisely. So you have parentheses, you can't see it, but I'll read it as I type in. Parentheses 1 minus, parentheses, 1 plus 0.00625, close parentheses, to the negative 60th power, close parentheses, so now we close this one, all divided by 0.00625. And that's just a number. That is 49.9053. And I'm taking it to 4 decimal places because it hasn't told me what to round to yet. Last step to solve for x, well, now we just divide by this number to cancel it out. So that's x is equal to 20,000 divided by 49.9053. So 400.759. Let's see. To determine the monthly payment of a 5-year loan, rounded to the nearest cent. So it looks like it's going to cost us about $400.76 per month. Okay. So now we run into a bit more of a problem. So for part B, it says the affordable monthly payment is actually $300. So what we calculated was it would cost us this much money, but we can't afford that. What we can afford is $300 as our monthly payment. What that means is we won't be able to take out as big of a loan. So instead of taking out this $20,000 loan that we took out before, we'll need to pay a larger down payment to subtract the total cost of the loan. So in this case, our down payment is the unknown amount. So let's see how this impacts the problem. So the amount that we'll have to take out the loan for, that's going to be the full price of the, oh, sorry, that's too many zeros. The full price of the car? I guess the full price of, the car, minus whatever we have as the down payment. So this time we don't know the down payment. So I'll call it D. And then for the rest of it, we actually do know the formula. The monthly payment, we can only afford $300, so that will be $300. Here we'll have 1 minus 1 plus the same percentage, 0.00625. Same loan amount, so 5 years is 60 months, all divided by 0.00625. So now we need to solve for D from here. So we get 21,000 minus D is equal to 300. Now this piece here, we actually already did this calculation. We found before that was 49.9053, so we'll leave it as the same amount. So 21,000 minus D is equal to 300 times 49.90530,818, and that is $14,971.59. Next up, we need to solve for D from here, so we'll minus 21,000 on both sides. Negative D is equal to this minus 21,000 on the calculator, negative 6028.41. We divide by negative 1 on both sides, and we find that the down payment we have to pay is $6,028 when we round it to the nearest dollar. So in order to have a smaller amount that we pay each month, we have to pay more of it up front via our down payment. Okay, so we are actually done with these two problems. For problem 5, let's see. Jim is looking to buy a vacation home for $172,600 near his favorite southern beach. The formula to complete a mortgage payment, M, is M equals, wow, this is a crazy formula, where P is the principal amount of the loan, R is the monthly interest rate, and N is the number of monthly payments. Jim's bank offers a monthly interest rate of 0.305% for a 15-year mortgage. So we have a similar situation. He wants to buy this vacation home. He can't afford to pay it all at once, so he's going to pay it back over 15 years. But he's going to be charged a small percentage of interest in order to allow him to borrow the money. But what that will mean is he'll have to pay back more money over time. So let's figure out some things about this. So with now no down payment, determine Jim's mortgage payment rounded to the nearest dollar. So for part A, he's going to take out a loan for the whole value of the vacation home. So let's see. Determine Jim's mortgage payment. So M is unknown. His principal loan, the initial amount, is going to be the whole cost of the house with no down payment. The rate that he's going to be charged interest at is this percentage, but we have to convert it to a decimal, so it's 0.00305 times 1 plus 0.00305, all to the nth power. Let's see what N is. N is the number of monthly payments. If it takes him 15 years to pay it back, then he'll pay it back in 15 times 12 months. That's 180 months. All divided by 1 plus 0.00305, all to the 180th power, minus 1. So this whole side is actually just numbers. So as long as you're careful about how you put this in on the calculator, using parentheses here and parentheses here, you should be able to compute it all at once. So 172,600 times parentheses 0.00305, open parentheses, 1 plus 0.00305, close parentheses, to the 180th power, close parentheses, now we've done our whole numerator, divided by open parentheses, 1 plus 0.00305, close parentheses, to the 180th power, minus 1, close parentheses. It looks like his monthly payment for his mortgage will be $1,247. Because it's supposed to be rounded to the nearest dollar. Algebraically determine and state the down payment rounded to the nearest dollar that Jim needs to make in order for his mortgage payment to be $1,100. So similar to the last problem, Jim can't afford this mortgage payment. So to reduce it, he's going to take out less money by paying a down payment, some of the cost of the house, up front. So however much he pays up front, what that will mean is he'll have the mortgage payment is equal to, well, the amount he takes out for his loan will be the cost of the vacation home minus how much of a down payment he's paying. So we'll call that X. Now the rest of this is actually all the same because the rate and the length of the mortgage are not changing. So we'll have 0.00305, 1 plus 0.00305 to the 180th power, all divided by 1 plus 0.00305 to the 180th power minus 1. Now, there's one thing we forgot to fill in here. We actually know the mortgage payment that he can afford is $1,100. So rather than leave this as M, we should plug in 1,100 right here. All right, so this looks pretty bad, but this is actually all numbers and operations. So let's compute the value of that. So again, if you're careful about parentheses here and here and here and here, then you should be able to get a nice solution for it. So plugging in on my calculator gives me 1,100 is equal to the red bits. I'll just put it at the end. So I'll leave this 172,600 minus our down payments. The red bit is 0.007228, rounding 4 decimal places that have values. Now to solve for X, an easy way to solve for it would be to divide by this thing that we're multiplying by. So that's going to give us an easier equation to solve. So these cancel out. 1,100 divided by 0.007228. So that gives us 151,185.9436 is equal to 172,600 minus X. Solving for X from here, we subtract this on both sides. Using the calculator, 172,600, that gives us negative X is equal to negative 20,414.05645. Dividing by negative 1 on both sides gives us X is equal to $20,414. So it looks like he'll have to pay out a pretty substantial down payment of over $20,000 to reduce his mortgage payment. Now, these are more than just Algebra 2 Regents questions, these last two. These are questions that you may actually have to consider when you're thinking about making a purchase in your future. So the vocabulary of down payment, the amount that you pay up front, and taking out a loan, the amount you'll pay back over time, are very important concepts to being kind of an adult and being able to afford things that you might want. I hope this was helpful, guys. It was an extra credit homework, so glad you made it this far. See you in class.